Hey guys, it's Cardinality, and today we're going to be going over this guide over here. It's a guide on exploratory data analysis, or EDA, created by the people at Google Cloud, and is probably the best guide I've seen that combines low-level concepts and goes into depth about the different types of statistical tests and stuff you can do, different graphs you can create, but at the same time keeps it high level enough and is short enough to where you can actually read it all in one day. We're going to be going through chapters 1 and 2 on the guide with code, and I'm going to walk you through exactly how I would work through this guide in order to perform an exploratory data analysis on my data. Alright, so now let's talk about the data we'll actually be using to perform our EDA on. It's going to be a really special data set today. So I've been using this app for the last couple of weeks, Rise. They're the sponsors of today's video. And Rise is a productivity tracking app, which tracks your productivity over time throughout the day. And for people like me, and presumably like you, who spend a lot of their day on a computer, I spend easily over 8 hours of my day on a computer between my day job, consulting, and YouTube. It's a great way for me to see exactly where my time is going and what I'm doing and how productive I'm being in that time. We're going to download the data as a CSV by just going to this thing over here, File, Preferences, give it a second, and then we can go ahead and download the data over here. So I've already downloaded the data and I've actually cleaned it up, and you can see the process of me cleaning the data on my TikTok or Instagram videos linked in the description below. I decided to separate it out from this video because it's a relatively simple process because the data comes out so clean anyways, and I wanted to focus this video on the actual EDA. But Rise graciously enough sponsored this video and let me use their tool. I've been checking it out for the last couple of weeks. The insights we're going to be getting out of the EDA today are going to be quite exciting, and I really like the tool, and the fact that I've been using it for the last couple of weeks, it's actually helped me improve my productivity quite substantially. So if you're at all interested in trying out Rise for yourself, be sure to use my code right over here, Cardinality, link in the description below, and be one of the first 1,000 people to get 25% off your first 3 months of Rise. And everyone gets a 14-day free trial if you're at all interested. So if you're interested, support me by supporting my sponsors. Rise in the description below. Thank you guys so much, and let's get on with the video. Okay, so let's go ahead and get started. So first thing we're going to do, obviously open up our code editor. I've gone ahead and created a blank workbook with all of the different, with Markdown showing all the different things that we'll be needing to add in to our workbook. And you can feel free to download that in the description below. So getting started, obviously the first thing we need to do is we need to import the libraries we'll need for this project. Usually what I do is I'll import them as I need them, but because I know what we're going to need ahead of time, I can just import them right now. So you first have your obvious, pandas and numpy standard libraries, but then after that, we have an interesting library called missing no, which we'll be using for missing values inside our data sets, and I'll show you how that works in a bit. Then we go ahead and add our graphing library. So we have Plotly, we have Seaborn, we have Matplotlib. We'll go ahead and add that stuff in. And then we will add SciPy for our Chi2 contingency testing, which we are going to be doing at the end. It's a really cool test to basically show if two categorical variables are independent of one another, and it's something you can really use to take your analyses, your EDAs, to the next level. All right, now that we have our libraries, let's go ahead and import our data sets. So like I mentioned earlier, I went ahead and did a data cleaning of this data set, and you remember, you can see where I got the data in the sponsor spotlight, and you can see how I cleaned the data on the Instagram and TikToks that I have posted with this video. But basically I created a pickle file, and a pickle file is basically just a Python object. So you can save a Python object in your computer. That way when you import it, it imports basically exactly as you saved it. So I've actually kind of stopped using CSVs, and I've started moving everything to the pickle file format because it allows me to save things like data types, indexes more easily, and it helps me avoid errors where oftentimes when I'll open a CSV using Excel, it'll drop leading zero. So I want to avoid stuff like that, and that is what the pickle file is great at helping me with. So let's go ahead and first run our imports. And I'm going to use my minimal DS environment, which I have a video that is linked above that you can watch to see how I actually set up that environment. And then we're going to import our data and take a small preview of it. So as you can see, we have a start time and end time, the total seconds, so basically the seconds between the start time and the end time, the day of the week, the title, the URL, the base URL, which in the data cleaning video, I actually show you how I got that base URL. The base URL doesn't come with the default data set. I went ahead and created it on my own. And let's see if I can scroll down and scroll in this direction a little bit. Our bundle ID and our category. So we have a couple of great columns over here. We have a numerical column over here. We have some date columns in the start time and end time. and then the rest are categorical. So we're going to have some good analyses to do with this data over here. So now that we previewed the data, let's go ahead and get started. So if you look at the Google guide, you'll see on page 4 and 5, we start off with something called descriptive analysis, chapter 2.1 in the guide. And another word for this is univariate analysis. So the first aspect of univariate analysis, you'll see that we have the 4 major data types that they specified, or attribute types I should call them. You have a common, numerical, categorical, and textual. And personally, I would actually add dates to the end of this as well, because dates do have to be, they're kind of like numbers, but they have to be treated slightly differently. So let's go ahead with common. Remember, if you look under attribute type statistic calculation, the first thing we need to figure out is what data types do we have. So let's go ahead and do our normal data import, which is the pandas file, or the variable of the data frame, and then do D types, and I'm going to hit Shift Enter. And you can see we have our start time specified in a certain, not zip code, time zone over here. So the Western United States, basically, the West Coast time, Pacific time. And then we have our seconds, which is a float 64, and the rest of the stuff seem to be objects, which is basically Python's way of saying pandas. So it looks like our data is formatted in some good data types. Again, I go over how I actually went ahead and cleaned up this data in those Instagram and TikTok videos that you can check out as well. Next, let's go ahead and use that missing no library that I pointed out earlier to actually show how we can like look at our missing values, because you'll see under common, the common attribute type under statistics/calculation, missing values is the second thing we need to check out. All right, so missing values, let's go ahead and do this. So MS-no, remember that's that missing no library we imported at the beginning, dot matrix, and then we enclose our data frame in that function call. I hit Shift Enter, and you can see we get each of our categories, each of our variables, our columns, and we can see how many variables are missing, or how many rows are missing. So white signifies missing, and gray signifies that the value is there. So it looks like for start time and end time, and total seconds and day of the week, and bundle ID and category, there are no missing variables, or no missing rows. But it looks like for title URL and base URL, there are some missing values. And I verified this independently. It looks like this is an accurate representation of our missing values. And this is a very important step in any EDA. You want to make sure you understand exactly what's missing. That way you can determine what you want to do with this in the future. So in this data set, this is perfectly fine. We are not going to be too worried about this right now. But if you were to actually try and execute a machine learning algorithm or create an algorithm using this data, you might want to deal with these missing values. But for today's purposes, we're not too worried about it. There's another cool feature that the missing no library has, which allows you to create a heat map. So that's literally just msno.heatmap data import, and I hit Shift Enter, and you see what we get is we get a heat map of the variables that have missing values in them and how they correlate to one another. And the reason we have this, the reason this could be useful, right, is this can tell us if there are variables that have a correlation to one another when values are missing. So for example, you'll see the URL variable and the base URL variable, it looks like there's a one-to-one match. Whenever URL is missing, base URL is missing as well. Now, obviously this makes sense because the base URL is derived from the URL column. And in this example, it's fairly obvious, but say you had 50 rows of data or 50 columns of data, right? Then this might be a very easy way to quickly see, okay, which of these things are related to one another. And there's a couple of important reasons that might matter, right? In machine learning algorithms, there's this thing called multi-collinearity that we want to avoid. And this is one signal that you might have variables that are very closely tied to one another. And we might want to drop one of them. So in a machine learning algorithm, we'd probably want to drop either the URL or the base URL. I personally would probably drop the URL because it has a bunch of extra information that's not too important. The base URL is usually what we're more worried about. So this heat map gives you a good idea of how missing values might be related to each other. So like the Google guide says, we start off with a common attribute type, then we go to statistics/calculation. We've looked at our data types and we've looked at our missing values. Awesome. So we've done the very first steps of EDA, gotten a very basic idea of what's going on. Let's go ahead and see what we can do with our numerical variables. All right, so now we're looking at our numerical data types. So as you'll see in the Google guide under statistics/calculation for numerical, we have our quantile statistics and our descriptive statistics and a distribution histogram. I'm actually going to be combining the quantile and descriptive statistics because they're super easy to find in Python, in Pandas specifically. So your quantile statistics are things like your Q1, Q2, Q3, min, max, range, and interquartile range. What does that mean? Which value in your column signifies the first quarter of results, which is the second quarter of results. That's Q2. That's also known as the median, meaning that half of the values are on one side of it and half are on the other side. What's Q3 and what's Q4? The interquartile range is basically the range between your Q3 and your Q1, which signifies the middle 50% of your values. And then you have your min-max, minimum, maximum values, and then range, which is the maximum minus the minimum. And those are your quantile statistics. Then you have your descriptive statistics, your mean, mode, standard deviation, median, absolute deviation, kurtosis, and skewness. So we're not going to worry too much about kurtosis and skewness in this discussion, but we're going to be talking about mean, mode, standard deviation, median, and absolute deviation. What you should do, though, is after you watch this video, try and use this data to go ahead and figure out what skew and kurtosis are for this data set. So it's super simple in Pandas. We're just going to go ahead and do our DataFrame.describe, and you'll see we get a count, the mean, the standard deviation, minimum, maximum, and the first, second, and third quartiles of our data. So that'll give you a good idea of how this data is distributed. And I like to call these things broadly the measures of central tendency. Really, that refers to your mean and median, which are over here and over here. The 50% is also your median. If you think about it, if you divide your data into quartiles, the middle quartile is going to be your median. So that's the first thing we need to do. We've done our quantile statistics and our descriptive statistics according to the guide, right? So then the next thing we might want to do is, this is based on the total seconds column, right? We actually might want to see how this looks at the minute level. So for example, 87 doesn't mean too much to me. I mean, I know it's a minute and a half, but it might be more useful to see this as minutes. How many minutes am I spending on an application at a time, right? And so if we go ahead and divide everything by 60, then you'll see it looks like I spend about a minute and a half, like I said earlier, on an application at a time with a standard deviation of about 3 minutes. And it looks like the median would be about half of a minute, otherwise known as 30 seconds. Now, one interesting thing is I'm wondering why, do I really switch through apps that frequently? Maybe I do. I would like to think that when I'm coding, I'm actually consistently on an app for a while, but maybe Rise, the application, is actually recording me going between my documentation and my code as me going through multiple different applications. And also I could see there being these time periods where I'm very focused for a couple of hours, but then there's a time period where I'm switching through apps very, very quickly, and those two kind of balance each other out. So what this really tells me is that we have a heavy distribution when your mean is significantly higher than your median, right? What that means is that you have a lot of outliers on the right side of your graph, meaning that I have a lot of very long focused sections, which is also this maximum over here, which says 67 minutes, right? Where I'm just doing one thing for a long time. And the median being so low tells me that let me rephrase that. The mean being this high tells me that I have a couple of very, very long focus sections. But the median being this low tells me that the majority of my time I've spent less than a minute or less doing just switching between applications and stuff. So I spend a minute or less on an application, and that's why the mean and the median are so different from each other. And that's something that's really important to remember when you're doing an EDA. You need to be able to translate what you learn, what you're discovering, into prose, into something that you can actually tell someone. And so the significant difference between this mean and this median tell me that I have a couple of very long focus time partitions separated by a bunch of things where I'm just switching through apps very, very quickly, at least according to Rise. So that's something that's really important to remember whenever you do any kind of analysis. Any analysis you do is not very useful if you can't translate it into some sentence that you can explain to basically anyone. Next, I'm going to do something, we have the distribution histogram over here, right? Histograms are great. I believe violin plots are slightly better. in that they, have the same information as a histogram, plus they actually also show the distribution in a more elegant format, in my opinion. So let's go ahead and add in a violin plot. So px over here refers to plotly expressed. Remember, we imported that at the beginning of the video, or at the beginning of this coding tutorial. Then we do data import, that's our data frame. Our x equals total seconds, and then we do box equals true. And what this is going to do is this is basically going to add a box plot like on top of our violin plot. And then points equals all will basically draw out the individual points as well. And let's just go ahead and run this code so you can see what I actually mean. And you'll see over here, we have our nice violin plot, which shows the distribution of our values. So our maximum values all the way over here. And it's kind of like I said, right? The vast majority of our values are over here, but I have a couple of focus sections all the way out here, which are heavily skewing all the results, right? So you'll have like stuff over here. It looks like there was one thing where I was here for 4,026 seconds, which is about an hour, I believe. And what that probably means is that is probably a meeting where I didn't click on anything else. I was like in the meeting app the entire time. So that's probably a good signal of one like very, very long meeting. And we can go ahead and check that value to see if that's true as well. Actually, total seconds equals 4,026. Why don't we check that out? Why don't we go ahead and take a look at it? So I'm going to go and type in data import, and then we're going to say data import, and then we're going to look at our total seconds column, total seconds, and then we're going to say that equals, and then we're going to get the maximum value basically, dot max. Whoops, I have to enclose that. And yep, Microsoft Teams. So it looks like I was basically in a meeting for a very long time that day, and I was completely undistracted in that meeting. It's very rare that I'm in a meeting and I've literally like only been on Teams and done nothing else. Usually because in most meetings there's like parts you pay attention to, there's parts you don't pay much attention to, and you kind of waver in and out between those parts as long as you're contributing what you need to be contributing to the meeting. So again, our EDA has shown us that our maximum value is this meeting over here. And it looks like we have a couple of other ones. Let's see, 2,171. I want to see if I can find out what this one is. Okay, so 2171.0. And it looks like that was me in Notion doing some documentation. Okay, yeah, Excel for data analyst notes. Yeah, so basically this is that course I had made earlier, and it looks like I was just on it for a solid, I'm guessing that's maybe like 45 minutes or something. I was just on it for that long, working on the notes for that course. So that makes sense as well, because the Excel course, I don't have to look at documentation. I don't have to look at websites and stuff for that. I can kind of just do it off the top of my head. But for a lot of the work I do at the office, I have to keep switching between documentation and like online and what I have in Notion or whatever. So this is another great way to start off your EDA. And you can see we have this box plot in here, which is all good and well, but the violin plot I find a lot more interesting and gives us a lot more information. And it gives us more information than even a histogram, in my opinion. And they just kind of look pretty as well, especially if you have a couple of these together. So that is a violin plot of our data. So far, we've done a couple of things, right? We've gone through our common data attribute types, and we've looked at what are all the data types of the data frame. We've looked at what are all the missing values, and then we went to numerical attribute type, and then we've looked at our quantile statistics, our descriptive statistics, and now we've just finished our distribution histogram, which I've actually used as a violin plot. You can do a histogram as well. Actually, let's go ahead and do a histogram. All right, so let's go ahead and make a distribution histogram. So I'm going to do something really simple. So we're just going to go ahead and use Plotly again. And as you can see, PX, Plotly Express, histogram, our data frame over here. And what is the X variable in our histogram? So total seconds. And then I want there to be a violin plot as well. And we will have the range be 0 until the maximum value. If I run that, okay, so it looks like the bins it chose were 10-second bins. Okay, that makes sense. So it looks like the majority of my time, I think the straight majority actually, is spent anywhere from 10 to 30 seconds on an application. And that would jive with this Violin plot we have over here, which, you know, jive with what we had earlier. But what if I want to change this to show like 30-second increments, right? What we can do then is we can go ahead and add a bin count where we basically take the max seconds divided by 30, and we'll get something similar, right? And then we need to make sure that it's an integer. If it's not perfectly divisible by 30, then it won't quite work. But it looks like we have what look like 60-second bins? 50-second bins, sorry. And you can see more or less the same pattern shows up over here. Now, I think this is an okay histogram, right? Let's see if we can go ahead and improve this a little bit. So I'm going to go ahead and use the PdCut method, which will allow us to actually create our own bins. And I'm going to create the bins using the total seconds column, and then we want to have the same bin count as I specified earlier in that bin count variable. And then what we're going to do is we're going to go ahead and create a lambda function. Remember what lambda functions allow you to do is that if you use it with the apply method, it allows you to execute on it allows you to apply a function row by row. So what we're doing over here is we've created this total seconds bin column over here, and I'll show you what that does in a second. And then we've created this, and then we're going to take that data and we're going to say row by row, if the total seconds is 0, like if the lower end of that bin is 0, or sorry, it will be 0 if the bin is less than 0. So basically, it doesn't create a bin lower than 0. Otherwise, it'll just be the value on the lower hand side. And you'll see what that means in a second. And then we're going to go ahead and create a histogram where we count every value and then reset the index. And then we're just going to go ahead and create our histogram. So first thing, let me go ahead and show you what the cut actually does. So let's go ahead and copy this over here. I'll put it in a new cell, and then we'll go ahead and show you. So you'll see on this end over here, the total second bins column, we created a column over here which has a lower value and an upper value of every bin, and you'll see they're about 30 seconds apart. Slightly different now, again, because it doesn't like evenly cut itself, we have to kind of do it this way. And then you'll see this -4 over here. This is what that whole lambda function was supposed to deal with. If something is -4, basically if it's less than 0, then we'll go ahead and just round it up to 0. Because you'll see what I do next is then I take, let's go ahead and copy this over here. I go ahead and take the left value in that bin and use that. So you see the left value over here, 60.09, I turn it into an integer and put it over there. 90 turns into, or 90.134 turns into 90. This turns into 0, the -4. This turns into 30. And now these are the actual bins we'll be using. Everything will be classified as 0, 30, 60, 90, and then it kind of deviates from there. But at the end of the day, those are the ones I really care about because that's where the majority of my data is anyways. So those were those two first values over there. And then we go ahead and do histogram data group by total second bins lower. That's those bins I mentioned just now. Dot count reset index, or basically counting the number of bins there are, and then we're creating a histogram with that data. So you'll see we're creating a data frame of the histogram, right? And you'll see why we do that in a second. So for 0 seconds, it looks like 50% of our values, and that's what we're calculating over here. We're calculating the percentage of the total values. 50% of our values are less than 30 seconds. The next 18% are less than 1 minute, basically. So because remember, this bin is from 30 seconds to 1 minute. And then 8% are from 1 minute to 1.5 minutes. And then we can go ahead and create a really cool chart called a Pareto chart using this. So I'll show you what these things do individually. So first of all, we just go ahead and make some subplots, and then we go ahead and this is Go is another iteration of the Plotly function, of the Plotly library. And what we're doing over here is we're creating a bar chart with the X histogram data, total second bins lower, and then our Y value, how high the bars will be total second bins. And then the name will be the number of instances. And secondary Y equals false for now. And then we're going to add a trace, basically add something else on top of that figure. And it's going to be a scatter plot. So for some reason, Plotly Go, which is another iteration of like Plotly Express. So Plotly Express is basically just a more syntactically simple version of Plotly Go, which was the original one. For some reason, scatter plots, line plots are just scatter plots with a line on them. I don't know why they don't just call them a line plot. But we're going to be taking percent of total and plotting that as our Y with the same X value. And we're going to call it the percent of instances. And then that is our secondary Y. That's what we're calling this true over here. And then we're going to update the layout by adding a histogram. So you'll see we use this fig. We're referring to that fig thing, which I created over here. Fig equals subplots over here. And then we're updating the layout to add a title. And then we're adding our x-axis. The title will be seconds. And then the y-axis, the title will be the first one will be the number of instances, and the second one will be the percent of instances, and then we'll show the figure. So if you plot that, you'll see we get this very pretty figure that shows us that 50% of our values are derived from just the 0 to 30%, 0 to 30 second bucket, which makes sense. Remember, our median was 30 seconds, right? So this may seem a little bit complicated, but literally I'm just adding one thing on top of another into the chart. So take a good look at this code and try it out for yourself. And this is one of those things, it's one of the reasons that I typically don't plot all that much in Python. It's a lot easier to just put this inside like a Tableau workbook or something. But sometimes you kind of just have to put it in Python, or it makes it easier for the user because everything's in like one easy to digest area, or because these diagrams, like Plotly diagrams, are a lot more customizable than what you have in Tableau. All right, now we're 1/3 the way through the univariate analysis section. We're going to go ahead and look at categorical attribute types, and there are two things we need to worry about, something called cardinality and unique counts. So cardinality refers to, so actually let's back it up for a second. What are categorical variables? They're variables, they're basically your string variable types for the most part. And they're things like, you know, male, female, they're things like country, so US, you know, United Kingdom, Germany, India, China, stuff like that. Those are categorical variables. Postal codes, I would actually argue, are a form of categorical variable because there's, well, I mean, I guess there is a sort of numerical correlation to them, like Texas, like zip codes within a certain area, at least in the US, like are numerically very similar to one another, but not really, you know, at the end of the day, it is a categorical variable. So with categorical variables, there's a couple of different univariate analyses you can do with them. You can do a cardinality analysis or a unique counts analysis, right? So cardinality is basically the number of unique values for the categorical variable. So with, for example, with gender, typically, and you know, in most forms, there are two options, right? You know, beyond that, there are more now, but typically you have two options in a gender form. And so the cardinality would be 2. And the other one is unique counts, which are the number of occurrences for each unique value of the categorical attribute. So for example, a great example, on my YouTube metrics only recognize 2 genders. They say male or female. And what they'll say is that, so the cardinality of that would be 2. But the unique counts, I don't know what the exact counts are, but like my audience is like 90-something% male and like 10, like at most 10% female. I don't even think it hits double digits, which, women, why don't you want to watch me? If anyone has any tips on how I could, you know, possibly expand that audience, I would like to, you know, include everyone in the conversation we have on this channel where we're teaching people how to get a great paying job in analytics. But the unique counts would be something like that percentage, except I don't know what the actual number is. So what I'm going to do is I need to do this for a couple of values. Remember, we had a data frame with a lot of different values, or with a lot of different categorical variables inside it. And so if I'm going to be repeating a function over and over again, if I'm going to be repeating a set of code over and over again, I might as well create a function. So let's go ahead and do that. We'll call it our cardinality Pareto. And I'll show you what that means in a second. And I probably should have explained Pareto a little bit better earlier. A Pareto is basically a which combination in descending order of your categories adds up to 80% of the totality of your results. And the reason is, this follows a Pareto Principle where, like, it's said that 80% of results come from 20% of effort or something like that, right? Where, and I'd say that, broadly speaking, that probably is true. Like the bulk of any, like on any task that needs to be completed, the bulk of like the actual benefit can be achieved with just 20% of the effort. Now that being said, and that's like where I'd say, you kind of get like good enough, but that other 20% that you put in, that gets the other 80% you put in to get that last 20% is kind of what separates the excellent work from like the good work. Is the person willing to put in that extra 80% to get that small 20% that's left over. So that's a Pareto Principle. It's almost a natural phenomenon in how common it is in like real life. You'll go to factories, you can go to like productivity metrics, and you'll see the Pareto Principle is basically everywhere. Even with your own life, you'll find if you're a college student and you're studying, you can probably learn 80% of the material with 20% of the number of hours you put in studying. And, that'll get you a B, but getting that A, that last portion over there, that's the hardest part. And that's where, the last 80% of effort comes in. So we're creating our function over here. And the first thing I'm going to do is I'm going to create a data frame called temp inside our function, right? And what we're going to do is we took in the data frame and we took in the column, right? So what we wanted to do is we want to create a function that will give us a cardinality and a Pareto of that cardinality. So we're creating a data frame called temp, which basically limits our data frame to that one column. And we're going to do a value counts method on it and then reset the index. What is a value counts method? Basically what it does is it takes a categorical column and it will take every unique variable, every unique value in that categorical column, and then it will count the number of instances of that. So basically it's doing the whole cardinality thing and the unique counts thing at the same time. Go ahead and try it out with some categorical data you might have lying around. Next, we're going to create a column called percent of total, where we take that column, the one we're specifying, and then dividing it by the sum. So we took our value counts, right? And we're going to divide it by the total value to see how much does each category contribute to the whole. Then we'll go ahead and do something called a cum-sum, cumulative sum, cum-sum, which is basically a running total. Okay? A cum-sum is basically a running total. That way we run up the total. And then we're going to return the data frame called temp. And let's go ahead and try it out on our day of week data frame variable, or day of week column. So we have the cardinality Pareto over here. Data import is our data frame. And then day of week is the column. So I'm going to go ahead and run this. And you'll see for every day of the week, we now have the number of times that we saw that value, the percent of total, and the running percent of total. So it looks like 80% of my work, or well, I guess this isn't about, that's not what this section means. Basically, this is counting the number of instances I switch apps, right? So 80% of my app switches happen on Tuesday, Thursday, Monday, and Wednesday. And, that makes sense. I'm just on my computer less on Fridays, Sundays, and Saturdays. I'm still working on those days, but I'm definitely working less. And you can see, like obviously like Friday, I'm doing the least app switching. I probably do, of the weekdays, I probably work the least on Fridays, as does probably everyone, honestly. And I found it funny, and you'll see later in this analysis, we'll see this everywhere. Tuesday seems to be the day that I actually like do the most active work as far as like switching through a bunch of apps, doing a bunch of different things. And this kind of makes sense to me. Monday is a day where I am addressing a lot. There's a lot of like just kind of menial stuff I have to get out of the way on Monday mornings. It's like weekly reports and stuff like that. So that eats up a good section of my days on Mondays. And then Tuesdays is usually when I actually start getting like work that has to get done for that week. That's when I'm like planning it and executing on it. I think I might be able to, there's probably a more effective way I could handle my schedule, but that's what this EDA is amazing for. I am actually finding out, okay, so it looks like I'm a lot more effective on Tuesdays and Mondays. Maybe I can restructure my Mondays to be a lot more effective. Maybe on Sunday evening, I need to like get all my tasks together, or more, or probably even better, what I should do is it looks like I have a lot of free time on Fridays. Why don't I structure out my next Monday on my Friday afternoons? It looks like I have some free time on Fridays anyways. Might as well put in that little bit of extra effort. That way I get more productivity out of Monday. And this is what is the wonderful part of data analysis. I didn't know that Tuesday was my most active day. And I'm drawing a bit of a correlation over here based on, or I'm drawing a causation over here based on some correlation. But part of that's because I also like know what my schedule is kind of like. So I'm like, okay, I'm putting together some pieces to see how this all works. But this is the exciting part about data analysis. I'm seeing some real tangible things I might be able to do to improve my productivity. And so what I could probably do is on Fridays, I could probably, really structure out exactly what I'm going to do on Monday and how I'm going to hit the ground running. I think that actually might be a better way to improve my performance on Mondays. So we've done that for day of week. Let's see if we can do it for our other variables. So category basically talks about the different categories that Rise will categorize my different apps into. Documenting being the highest makes a lot of sense to me because recently, so this is data from the last 2 weeks, I've been working on creating a plan to build out a machine learning platform. And I use Notion and Confluence a lot, which would count as documenting. So that makes a lot of sense. Entertainment being the next highest, I guess that makes sense. I always have like a YouTube tab in the background playing something. So that probably does make a lot of sense. And I'll switch videos every like 5 minutes or something. So I guess entertainment does make sense as far as having the next highest number of app switches. And then, well, miscellaneous could be anything. Utility, I'm not really sure what's in utility. That's a good question. Messaging would be things like Teams and Slack when I'm actually like messaging people. Browsing would just be like regular internet. Email would be anything like Outlook or Gmail. Code, I have not been coding that much in the last 2 weeks, at least not for work. I've done, actually no, yeah, because I've been doing my Excel tutorial, which didn't involve any coding, and then I've been doing a lot of documenting, so I've not been coding that much in the last couple of weeks. So that makes a lot of sense. Meetings would not have a lot of app switches. I think I would spend a lot of time in meetings, but I wouldn't have a lot of app switches into meetings. And here's the thing. So it looks like video conferencing and meetings are held disparately. I actually should probably combine those two categories because they're, at least in a COVID world, they're like the same thing, right? Because all my meetings are done through video conference. Social media, that's interesting. I wonder what categorizes as social media. Probably LinkedIn for me. I don't access social media on my computer that much. I know that I had a couple of TikToks blow up recently, and I was like kind of just checking the performance on them. So like for me, what happens is whenever I post new content, I will like religiously check the metrics for the first couple of days. And then after that, I kind of like, stop caring. And I'm trying to like leave that habit because I don't, I think the only strategy for success, quite honestly, is just make great content, market it, like tell people about it and everything, but just make great content. And, if it does well, it does well. If it doesn't, it doesn't. And try and reflect on why certain things did well and certain things didn't do well. But, religiously checking metrics is probably not an effective use of time. And it's something I'm trying to do less. I've kind of like given into the guilty pleasure of like just, checking whenever I post something new. But I'm trying to like reduce that habit because it creates a lot of anxiety that I think is unnecessary. All right, then we have news. I don't check the news as often as I used to. I used to be a huge news junkie. And then I kind of started to realize that, at least for me personally, I didn't benefit a ton from always like listening or watching to breaking news because there's so much stuff happening in the world of which very little of it is actually important, at least to me. I'm sure it's important to someone, but to me. And I find that I'm a lot more interested in listening to and watching explanations of phenomena. So there's this great YouTuber called Kraut who does a lot of explanations on political science and like phenomenon and how societies function and how they form themselves. Like he did this great video on low trust societies versus high trust societies and how that explains the Greek debt crisis very recently. So I love watching that stuff because it actually helps me understand the world, which I think makes me a better voter. Living in the U.S. so properly, I'm in a democratic country where I believe that part of the responsibility is like voting is a right, sure, but I think being an informed voter is a responsibility. So I can see myself spending less time on news, and honestly, a lot of my like documentaries and stuff I watch are on YouTube, which might be classified as entertainment. So I watch very little like actual entertainment. There's TikTok, but that wouldn't be recorded by this app because I watch it on my phone. Which Rise, if you guys want to have a iPhone app, I would love, or if you could help integrate the iPhone's like tracking of like what like I do throughout the day, that'd be pretty cool too, because you know, my phone's another screen that needs to be tracked. Cool. And then design, product, finance, sales. Yeah, that makes sense. I don't do any of that stuff for the most part. I like how Twitter's an entirely separate category. All right. Wow, we're getting all kinds of information from this. All right, let's go ahead and do bundle ID. This basically is like, what app am I using the most? Brave, that makes sense. These two should probably be classified together. Brave and com.brave.browser. I wonder what the difference is between those two. Slack, that makes sense. Excel, I was doing the Excel tutorial the last 2 weeks, and the project plan I was creating in Excel. So that makes a lot of sense that Excel was the most used productivity app over here. Notion, Excel, and see, this is another thing, like this and this should be categorized together. So, you know, this is where our cardinality helps us, so we can actually see the individual values over here, and we see a couple of them probably need to be categorized together. This is where fuzzy matching might be really interesting. You should look that up and see if you're interested in that. Okay, so we have some stuff over here. All right, and then let's see what the next one is. Then we can do BaseUrl, see which URLs I'm on the most. YouTube, Google, like Gmail, basically, YouTube, LinkedIn. Interesting. Okay. Huh. A couple of interesting things over there. Cool. But that is basically how we do cardinality and unique counts. So the next thing that the guide talks about is textual analysis. I'm going to skip over it for this guide because I would like to create a kind of separate video on textual analysis, because I talk about things like document frequency and text frequency, which I think is a little bit beyond the scope of like beginner EDA stuff. Like it's not the stuff you want to worry about at the beginning. There's usually so much more data that you can worry about. Text analysis is like its own thing entirely. Plus, the data I have over here, I couldn't do much text analysis on it. Like the BaseUrl basically is my text analysis, but there's not much textual analysis due on this data, so we're going to be skipping that for now. All right, next we're going to be worrying about the date data type. So the Google guide actually talks about date data types towards the end, near, I believe it is 2.3. It calls it contextual analysis. But because dates are, it is a univariate analysis for the most part, I am just bringing it up over here. But 2.3, where it says time-based analysis, 2.3.1 in the guide, that's where you want to look if you want to see what the Google guide says about this, but I'm just going to put it over here in the video. So the first thing I'm going to do is I'm going to go ahead and create a hour column, split our data up into hours. So if you saw the data, you would have seen that I have the date, the hour, the minute, the second, minute and second. I'm not sure if there's any correlations over there that matter, but hours is probably something really cool over there. So what we're going to do is we're going to create a new column called start hour, which equals data import start time. That's our date column. .dt.hour. This will extract the hour value in the 24-hour format, so 0 through 23, basically, for our data. Then we're going to go ahead and group by start hour, and then count the category and reset the index again. And then we're going to go ahead and create a histogram. We're going to call it fig, px.histogram. And the reason I'm calling it fig, like the ones above it, is because, like, getting all these variable names gets really confusing after a while. And for a Jupyter notebook where, the stuff it's going to be running one after another, they can be named the same thing and it won't really make much of a difference. Because every figure is output one after another. So we're going to go ahead and make a histogram where we take the start hour and use 24 bins, because there's 24 hours in a day. We're going to go ahead and add a bar gap of 0.2. So basically in a histogram, normally the bars are like squeezed against each other. The bar gap will create a gap between each individual bar. That'll just be very helpful for readability purposes. So I'm going to go ahead and run that. And you'll see we have a histogram, which shows basically how many, app switches, right? Because it's just, I'm just counting up stuff. How many app switches are there per hour? So it looks like I do the most app switching at 10 o'clock in the morning, which makes a lot of sense. Usually in the morning, I'm going ahead and I'm planning stuff out, and I'm like kind of getting like the morning tasks out of the way. Usually the morning is when I do stuff that I kind of have to do to like kind of like KTLO is what we call it, keeping the lights on. That's usually when I do my like KTLO work. I do it in the morning. And in the afternoon, I do my more focused work. So there's going to be less app switching then. And you'll see there's obviously a break at around 12 when I take lunch. My lunches are, I very rarely like turn off the computer and go eat lunch. I'm usually always like on my computer eating lunch at the same time. But obviously that's going to drastically, like eating lunch and working at the same time, I'm not going to be as productive. And then you'll see it jumps back up at 1 o'clock where I'm doing more stuff again, almost as close to 1. And it kind of like, it goes down as the day goes away. And then usually what I'm wondering why it goes up from 5 to 6. I'm guessing it's because I end my office work at 5 and I start my YouTube and consulting work at 6, which probably that context switching allows me to like kind of refresh my mind and start over again. But you'll see I'm fairly active on my computer until about 1 a.m. Yeah, 1 a.m. And then usually after that I'm done for the day. So you'll see that I started about 8, 9, 10, and then go until about 1 a.m. doing stuff on my computer, just various things. So I probably should get some better work-life balance. This is it's kind of worrying that there's so much activity throughout all hours of the day except for the ones where I'm sleeping. All right, so that's our histogram. Now, what I really want to look at is the total seconds I spend per hour doing, like, working according to RISE, and let's see what that looks like, because I think that'll give us a more accurate view than just counting the number of app switches in a given hour. So we're just going to create a bar chart. So I created a table called hour bar histogram, data import .group by, and we're grouping by the start hour. And then we're going to count the total seconds, sum, reset index, and then plotly express again, .bar, and the data frame is going to be this one over here. And then we have our start hour and our total seconds. So let's go ahead and run that and see what we get. And you'll see it's basically the same graph over here. Oh, so it looks like I pick up again. What's 22 o'clock? That's 10, right? Is that 10 or is that 11? Because 0 would be 1 a.m., right? So this is 11. This is 10. Okay. And actually, you know what? That actually makes a lot of sense. So my dad's a big night owl, right? And like, watching him work at night growing up, I think, I don't know if it's a genetic thing or if it's like the way I was raised, but like, yeah, I'm very much a night owl. Like I tell everyone, like I get a lot of great work done between 10 to 2 a.m. So 10 p.m. to 2 a.m. And there's a weird period in the evening where I don't work as well, honestly. So that's actually, it's funny to see the data actually prove out what I know about myself, and that I'm a night owl, and like there's more work getting done at 22 o'clock, which in this case would be 10 o'clock, I believe. So it looks like after hours 6 and 22 are the best times. Oh, and you know what? Also, I'm usually cooking and eating dinner at this time of the day, and when I eat dinner, I don't work. Because I want to enjoy my dinner. So what I do is I actually order HelloFresh, which HelloFresh, please sponsor me. I actually use y'all's products, so make sure to sponsor me. But I will cook my dinner, and then HelloFresh, with each meal kit, basically, you get 2 servings, right? So I'll cook dinner and I'll eat that for lunch as well, right? That way I don't have to, take a break for lunch. But by cooking dinner, I want to enjoy that food because it's hot and fresh at that time, right? And so these 3 hours of your probably are like me doing my evening chores. Usually I'll go out for a walk, just like leave the apartment and everything. But yeah, no, this makes perfect sense. Again, data proven out what we already know. We can attach some numbers to my productivity throughout the day. Next, we're going to go ahead and look at we're going to do the same thing, but we're going to do it for dates. Or dates? Yes, dates. So I can see which dates I was more productive on. Okay, so it looks like February 21st, I was doing an unusually large amount of work. I wonder what that day was. That was a Monday. It must have been a crisis Monday in that case if I was doing that much work on a Monday. And oftentimes that'll happen. Something will happen over the weekend, and then on Monday you got to go deal with it. So yeah, no, that makes sense. And then we're going to do the same thing. We're going to do total seconds. And you'll see there's a correlation, but it is slightly different between the counts and the total seconds. And again, that Monday looks like it was particularly busy. It looks like Thursday is pretty busy as well, right? Because this would be Monday, Tuesday, Wednesday, Thursday. And that probably makes sense because on Thursdays, I do my live streams in the morning. So I'm on my computer for at least an hour longer on Thursdays. Instead of logging in at 8, instead of logging in at 9, I log in at 8, do my live stream, and then from 8 to 9, and then at 9, go ahead and start work. And then February 9th, it looks like there was nothing. I'm just guessing that for whatever reason, Rise just didn't record my activity on the 19th. All right, next we're going to go ahead and look at our bi/multivariate analysis on the Google guide that is 2.2, chapter 2.2. Bivariate analysis. I call it bi/multivariate analysis because you, well, I guess in the Google guide, it's only, yeah, no, it is actually only bivariate. This shouldn't be multivariate. It is only bivariate. So let's go ahead and actually change that. Yeah, bivariate analysis. And we're going to be doing some correlation analyses. So first, we're going to do a qualitative analysis. And what are qualitative analyses? Well, I call them non-quantitative analysis, where you don't have numbers, basically. So the qualitative analysis, if you look at 2.2.1, the one that they offer that I find quite interesting is comparing two categorical variables to one another. And you do this by creating something called a contingents table. I don't know why I called it a contingency table. It's actually called a contingents table, but you might hear me say contingency table a lot just because I think I'm just more used to the word contingency, like a contingency plan. And what that is it basically counts, if you have two variables, x and y, the number of times y appears for every x and vice versa. And you create one of those things in Pandas using something called a crosstab. And it's the same way in Excel, actually. You can do this analysis in Excel as well. So let us go ahead and create our crosstab, where we literally I'm going to call data crosstab, and I'm only going to use it for one of our categorical variables because you can just repeat the process over and over again for the different variables we have. pandas.crosstab data import day of week. So we want to do day of week versus category, and I'm going to remove the margins. Margins basically adds a total column at the end. I'm just going to remove that, and let's go ahead and run that. And we got our contingency table. So you can see on Friday, there are 33 instances of browsing versus Tuesday where there are 71. I'm guessing I'm just a lot more active on Tuesday. Oh, and you know what? I don't work on Friday evenings. I make it a point not to work on Friday evenings because I work all the other evenings of the week. So yeah, I literally work every other evening of the week. So I make it a point not to work Friday evenings. And if those of you that have been long-time watchers of the channel, you'll know that I actually used to do a live stream on Friday evenings, and I stopped those just because I needed a break, honestly. And it is the night everyone goes out, so that is probably why Friday has the least activity as well, because there's like very little evening activity on Fridays. Which, speaking of which, this is what I always tell people about EDAs, right? Now I have the question of, okay, what if I plotted every day or every hour of every day and see how they compare to one another? Something you might want to try out if you decide to download Rise and try this data out yourself. All right, so this is our contingents table. And then what we can do, so this is a qualitative analysis, right? Now what we can do is we can go ahead and turn this into a quantitative analysis by looking for correlations over here. So under quantitative analysis over here, right? I am going to go ahead and create a correlation matrix, which Pandas makes it super simple, just data crosstab .core, and you'll see the correlation between each of these variables. So, there's an interesting one over here where we can see browsing and code have a high correlation to one another, meaning that as I code more, I probably get I'm on the internet more as well, which makes a lot of sense because there's going to be a lot of checking of documentation. And another one might be, design and code. You have a lot of very interesting ones over here. I'm not sure what classifies as marketing on my activity, but I can check that out as well. But we have a quick correlation matrix over here. So this is the most simple form of quantitative analysis. If you look at chapter 2.2.2 on the Google guide, we are looking at quantitative analysis right now. And this is our simplest form of quantitative analysis. But let's go ahead and try and do a more advanced one. Okay, so now I want to see if there is a correlation between the day of the week and the total seconds I work, basically the amount of time I'm working, right? So let's go ahead and create our data frame for this. We're going to call it core, and we're going to do this thing called get dummies, which what that does is it one hot encodes our variables, and I'm only going to include day of week and total seconds. And the reason we need to one hot encode our variables is because if I convert every day into its constituent like number, then Monday is 0, Tuesday is 1, Wednesday is 3, and so on and so forth. And basically, it's going to presume ordinality, like. Or more than ordinality, no, because there is an order. It's going to presume scale. That, for example, Friday is 5 times as whatever as Tuesday, and that'll confuse our algorithm, or that'll confuse the confuse pandas, which is not what we want to do. There is no like Friday is not 5 times anything of what Tuesday is. Five times better maybe, but that's very much a subjective opinion. So we want to turn this into one hot encode our variables. Go ahead and look up one hot encoding, and you'll see what I mean when we do this. Next, I'm going to do this. This is just code I got from the internet. Basically, we're going to go ahead and create a big data frame, kind of a big NumPy data frame, NumPy array, we'll call it. That way we can create a heat map using the Seaborn library. We're going to create a matplotlib figure. And we're going to be using SNS, that stands for Seaborn, diverging palette. And then we're going to draw the heat map. So basically, we're going to take this, correlation over here. We're going to take this mask over here, which will help us determine our color intensity. Our CMap is basically the colors we're going to be using. And then we will go ahead and run this and see what we get. So we get this beautiful graph over here. If you want to know how to make this, go ahead and look up Seaborn correlation matrix. I think that's what you look up, and it'll be like the first result. And so we can see that there are not tremendous correlations between the day of the week and the number of seconds. Okay, yeah, so total seconds is over here. This is the column we're interested in, right? We want to see if there's any correlation over here, and it looks like not a tremendous one. It looks like there's probably one. The closest one is one on Friday, but that one's not amazing. So it looks like we don't have a great correlation to look at over here. But this is an example of a quantitative analysis, a quantitative bivariate analysis, basically making a correlation matrix. This is just a pictorial version of this chart we made up here. All right, so there might not be much of a correlation over there, but there has to be a correlation between weekend or weekday, right? If I create a category called weekend or weekday, and the number of hours worked, right? So let's go ahead and try that again. This is where EDA is, right? Like I didn't see much of a correlation in the individual days, but maybe there's one between whether a day is a weekend or not and how much I work. So let's go ahead and just create a quick column in our data import table called weekday or weekends, where I'm literally just doing a lambda function where it'll be 1 if X is a Monday, Tuesday, Wednesday, Thursday, or Friday. Otherwise, it'll be a 0. I guess you could kind of include Friday as a weekend, but we're not going to for our purposes. Then we're going to take the total second bins lower and convert that as, make sure that's an int. And then we're going to create a correlation matrix of weekday or weekends, total seconds, and total bins lower. So we'll see how that looks like. And it looks like we are getting a better correlation over here. If we take weekday or weekends, we have the strongest correlation we've seen so far. This is stronger than that Friday correlation we saw earlier between weekday or weekends and total seconds. Again, it doesn't look like a tremendous one, but this is the best one we've seen so far. Next, let's see what we do over here. We're going to go ahead and try... yes. Okay, so sorry, let me back it up for a second. So what we did over here is here's the problem, right? We were correlating every individual second value, so like 30 seconds, 30.5 seconds, 38 seconds, 32 seconds, with a weekday or weekend, which might not have any correlation at all. Basically, the length of time I'm on an app, that's what we were correlating, versus the weekday or weekend. There's no correlation over there. So what we're going to do now is we're going to create a new data frame, which will take the total seconds per day, group it by each individual day, and then assign that day a weekday or weekend and see if there's a correlation over there. And this is where it's really important to understand your data. I apologize, I completely forgot that's what I was doing over here. This is where it's really important to understand your data and understand why there might be problems. So if you think about it, right, what we were doing over here is we were finding a correlation between individual second values and our weekday or weekend, when really what we should be doing is finding a correlation between the total seconds worked in a day and a weekend or weekday. And if you see, we have a much stronger correlation over there. There is a correlation between whether a day is a weekend or a weekday and how much work I do that day, at least according to Rise. And then we can go ahead and just take a quick look at our crosstab again. And the reason I want to look at that crosstab is because I want to see if I can turn these into percentages. That just might be something that's useful for us, right? So what we're going to do is we're going to do the same thing. We're going to create the same crosstab, and we're just going to add this normalize index function over here, or a parameter over here. And what that does is that'll create a percentage on the row, like per index, basically per row. So on Fridays, 5% of my instances are spent browsing, 0.9% are spent on code and stuff like that. And that makes sense. I don't code that much on Fridays for sure. I'm usually like planning and documenting and stuff like that, if anything. And it looks like we, for example, do a lot more on Thursday of coding. Yeah, a lot more on Thursday of coding. And we're going like line by line, basically, right? And if you want to switch this, I think you can change this to say columns. And it'll go up and down from then. So, for example, now what this is telling me is that most of the coding is done on Wednesday, or the plurality of the coding is done on Wednesdays, and 90% of my coding is done on Thursday, Tuesday, and Wednesday, basically the middle of the week, which makes a lot of sense. It kind of jives with what we were talking about earlier. Again, this is a quantitative analysis of that qualitative crosstab that we created. And this is a cool, to me, this is magical, being able to turn two categorical variables into quantitative numbers I can actually show people in order to actually communicate, here's a actual correlation between, the data, between two things like the day of the week and what you do on that day of the week. All right, guys, so the final thing we're going to do is we're going to do another quantitative analysis, and this will be a chi-squared test, which allows us to test if two variables are independent of one another. Whoops, let's get rid of that. Oh, that was an accident. Which will allow us to test if two categorical variables are independent of one another. So the chi-squared test works by comparing two different variables to one another. You need to set your p-value ahead of time. I'm just going to set mine to 0.05, which is the standard p-value that gets set. And I'll go ahead and create a video where I talk about these types of statistical concepts later. But just know that you run the chi-squared test on two different variables. Make sure you set your p-value ahead of time. That way you're not. I don't think that specifically is p-hacking, but that way you're not cheating and trying to just change your p-value to find an interesting correlation. So what I need to do is I want to go through every categorical variable combination and see how they compare to one another. I want to go through every categorical variable and see how it compares to the category variable, which remember tells us what category of activity am I doing at that time, and see what chi-squared says. So we're going to go ahead and create a for loop, right, for each unique category. And then I'm going to go ahead and create a temporary data frame, which is just a copy of our regular data import data frame. And then I'm going to create this thing called temp category, which basically allows me to categorize everything as either part of the category I'm worried about or not part of the category I'm worried about. That's really important because chi-squared only works, in this case, only works with two variables. So you can't have multiple different classes, or you can't have multiple classes. You need to have it either is or it isn't part of this category. But we're going to run that for every single category. That's what we're running this for loop for. Then we're going to go ahead and create a crosstab of the temp category versus weekdays or weekends. Basically, we're trying to see, is there a relationship between an individual category, like entertainment or coding or something, and the weekday or weekend. Then we're going to go ahead and use the chi2 contingency method, which comes from the SciPy library, if you remember our imports from the beginning, and use that on the temporary crosstab that we created. So you have to create a crosstab and you can insert it in there. And then we're going to output our p-value, and I'm going to round it to 2 decimal places since 0.05 is the cutoff for us, and that has 2 decimal places. And then if the p-value is 1, then we'll just say there's not enough info. Because what happens is, if there's a category where there's no data inside it, it'll output a p-value of 1. So I needed to say there's no info over here. And then if the p-value is less than 0.5, not less than or equal to, less than 0.05, then we're going to say the category and weekdays/weekends are independent of one another, meaning that there's not much there's not a relation between the two. And if the output text is if it's above 0.05 and doesn't equal 1, Then we say the weekdays/weekends and that category are not independent, meaning there's some correlation between, there's some relationship between the two. And then we're just going to go ahead and print out that value. So if I go ahead and hit Shift Enter, then you'll see we go through each of these categories. So productivity versus weekdays/weekends. The p-value is 0.32. And it looks like productivity and weekdays/weekends are not independent, which makes perfect sense. I probably am using significantly more productivity tools on the weekdays versus the weekends. And this is, remember, on section 2.2.1 near the end of the Google Guide, right above contextual analysis. So there you go, guys. That is our EDA.